Hello everyone. Today's class we are going to see Unit 6 Optics MCQs Book Back 1 Mark. In Young's double slit experiment, the slit separation is doubled. To maintain the same fringe spacing on the screen to slit distance D must be changed to. The question is asked. The solution is, from the diagram we have D, small d, the distance between the double slits S1 and S2. A screen is placed parallel to the double slit at a distance D. That is, the distance between the slit and the screen is D. P is any point at a distance Y from O. The bandwidth beta is defined as the distance between any two consecutive bright or dark fringes, and it is given by beta is equal to lambda capital D divided by small d. You know, D is the distance between slit and the screen and small d is the distance between the slits. In the question it's given the slit separation is doubled. To maintain the same fringe spacing, that is beta, that is the fringe width, remains the same. What is the new position of that screen? It's asked. When the slit separation is doubled, the fringe width now becomes, here the fringe width is same, the wavelength is same, that is the wavelength of light source is same. Here D, this distance between the slit has been doubled. We need to find the new distance. The screen to the slit distance D must be changed to, we have to find. Lambda get cancelled. D and D will be getting cancelled. Therefore, the screen to slit distance D must be changed to 2D. The option A is the correct one. Two coherent monochromatic light beams of intensities I and 4I are superposed. The maximum and minimum possible intensities in the resulting beam are. It's asked. You can see the solution. We have learned that the intensity of light is proportional to square of amplitude. The resultant maximum intensity is I max proportional to A1 plus A2 the whole square. The resultant minimum intensity is I minimum proportional to A1 minus A2 the whole square. I proportional to A square. We can write I1 proportional to A1 square and I2 proportional to A2 square. So we can write I max proportional to square root of I1 plus square root of I2 the whole square. Similarly, given I1 is equal to I and I2 is equal to 4I. Therefore, we substitute the values of I1 and I2 here. Instead of I1 we put here I and instead of I2 we put here 4I. We simplify this by using the formula A plus B the whole square. It is A square plus B square plus 2AB. After simplifying, we get I max is equal to 9I. Similarly, we can write it for I minimum. Root of I1 minus root I2 the whole square is equal to, we substitute the values and simplify. We get the value of I minimum is I. So, I max is 9I and I minimum is I. Therefore, the option is option C, 9I and I. Thank you.